So for a function to be differentiable at a point, in this case at x equals 2, we know the function has to be continuous and smooth. So that's going to help me write two equations. Since I have two criteria, I'm going to write one equation to show that the two pieces of the piecewise function have to leave the function continuous, and one equation to show that that function has to be smooth. And really what smooth means is that the derivative from the left equals the derivative from the right. So here, flashback to last chapter. If the function f is continuous at x equals 2, then cx plus d has to equal x squared minus cx whenever x equals 2. So I can write 2c plus d, this is me plugging in 2 for x, equals 4 minus 2c. I'm just going to add 2c to both sides to put this in what I think of as standard form. So 4c plus d equals 4. If 4c plus d equals 4, then this function will be continuous. Now I need the function to be smooth, which means the derivative from the left equals the derivative from the right. So here, the derivative of cx plus d. Well, d is a constant, its derivative is 0. C is also a constant, so what I'm finding is I need the derivative of c times x. That's just c. That has to equal the derivative from the right. So from the right, the function is x squared minus cx. The derivative is 2x minus c. And again, this all has to be true if x equals 2. I'm going to plug in 2 for x. 2 times 2 is 4 minus c. I'm going to solve this equation for c. I get 2c equals 4. So c must equal 2. That's half of my answer. I've been asked to find c and d. Now I've got c. Since I have c, I can go back to that first equation to find the value of d. So 4 times 2 plus d equals 4. 8 plus d equals 4. And I find that d equals negative 4. Now here are two solutions. D equals negative 4, c equals 2. So I want to talk about question 4. I'll skip the stuff about continuity, that's from last chapter. So question C, is f differentiable at x equals 3? So here's the place where x equals 3. Essentially I need to figure out if f of x is smooth and continuous. So clearly it's continuous since I can draw the graph there without picking up my pencil. It also looks smooth. There's definitely not a vertical tangent and there is no corner or cusp. So I would say yes, because I want to give the formal answer. The limit as x approaches 3 from the left of f of x minus f of 3 over x minus 3 equals the derivative from right, so that would be the limit as x approaches 3 from the right, f of x minus f of 3 all over x minus 3. Question D asks, is f differentiable at x equals 0? Here the answer is no, because why? Because f of x is not continuous. At x equals 0. And I will have given an explanation for why f is not continuous at x equals 0 here for part B. For me, two integer x values at which f is differentiable. So I would say x equals 3 for the same reason I said in part C, and x equals 4 was my other option. Is there any labeled integer value of x at which f is continuous but not differentiable? That would be here at x equals 1. And then you just want to make sure you write out the reason, because the derivative from the left, so the limit as x approaches 1 from the left of f of x minus f of 1 over x minus 1 is not equal to